Hi, and welcome to the first installation of the Profitap talks. This is going to be a recurring series of talks we're going to have with Mike Pennacchi about various features and topics regarding network analysis and packet analysis. And yeah, we're going to start off with basic introduction, I would say. Let's keep it simple. My name is Roland Knall. I'm working for Profitap. Have been a Azure co-developer for the better part of 5 years now. Actually, it's 8 years now. And yeah, dabbling in network analysis and all kinds of packet analysis on a day-to-day basis. And with me is Mike. Mike,
Roland?
welcome.
Thank you. My name is Mike Pennacchi. I own a company here in Seattle, Washington called Network Protocol Specialists. For probably the last 30 years, I've been doing packet capture and analysis, and I've been working with Profitap on a number of projects, and especially with their IOTA product, and just getting in there and capturing packets, making sure people understand how to use this equipment properly, and getting to the root of problems.
Thank you. So for today's talk, for the first installation, we thought we'd start off with some light and easy discussion about span versus tap. I think we both have the experience when we talk with people about network analysis, then it's often a question of why do I need this anyway? And I have the switch and I can configure it to put all kind of stuff out there. That should be enough, right? So why don't we like the span ports? What do you say to that question?
Well, I'm going to start with a little bit about when I do like them. And I think we've got a lot of content on why it's best not to span. And I will say that, one of the more popular videos I have on YouTube is enabling span on a $35 switch, right? And, you work with Wireshark. There's times where we just need to get in the path of the packets. And if I've got a little switch and I'm trying to capture on one machine, maybe span's not so bad. But I can tell you, over my decades of network analysis experience, I have seen more problems caused by span. And in a lot of cases, we may not have even known that there was a problem. So when it comes to span, I have to say one of the first things that is a challenge with spanning is we are changing the switch configuration. And depending on the environment you're in, that could require change control. I had a case quite a few years ago at a bank where we spanned a link going out to one of their remote locations. And my desk that I was at was right by the help desk. And I sat down with one of their contractors. They typed in the span command. They typed it incorrectly. They typed it in correctly, not incorrectly. It was correct. And I went back over, sat down, and I could hear the help desk talking to somebody at the site we were spanning. And they said, "You're down right now?" And it just so happened that on that particular switch, every random number of times that you did a span, it would shut down that port. And so by spanning the port, we took it down, which was exactly the opposite of what we wanted in trying to troubleshoot a network problem.
Yeah, I mean, my initial network background is in OT networks, and there you have a similar issue. What people often don't realize, network equipment is now seen just as an extension of the cable, right? You have the switches, you put them there. Obviously, if you have more expensive switches, you do know that you need to configure them. But at a certain point in time, most people tend to see the switch just as a box where plug cables in, and it works miraculously due to protocols that are now over 40 years old in some cases. What people tend to forget is that a switch is actually a mini computer doing calculations. And by that, it's taking look at the network traffic, it's reacting to the network traffic. Coming from industrial networks, I mean, I'm one of those guys. I still own network hubs, real hubs, and I still enjoy the heck out of them because they're real world applications where a hub is actually superior to a single switch, especially in industrial Ethernet networks. So span ports for me is I agree. There are scenarios, especially when you're at the end of the line and you want to have a single host, a single application you want to mirror or monitor, where Spamboard can easily be the solution. But at the same time, you have to consider that you're not seeing what the network is transporting. You're seeing whatever the switch has interpreted, whatever the switch has optimized, changed, whatever he did to send out through that port. I mean, I'm not talking about now big stuff, but store and forward is a basic concept of nearly every switch out there, and store and forward kills you if you're doing hardcore analysis, especially when it comes to timing.
Yep.
So that's what I often get when I respond to people saying, "Oh, we have the spam port configuration and it's working fine." I'm saying, well, how do you address store and forward? Store and what?
Well, and the other part is, as our network infrastructure changes over time and we switch vendors, so do all of those different span commands. And, I've run into switches where we could only span transmit or receive. You couldn't span both. And so that idea that, we're having to change our monitoring infrastructure every time we change our switching infrastructure adds another layer that we have to take into consideration when we're doing our troubleshooting. So if we start separating those two and looking at the monitoring infrastructure as a separate piece, so that we're saying we're going to implement a monitoring infrastructure that is independent of our switching infrastructure, then either one of those can change independent of the other without us having to relearn all those commands and so on.
You brought up an interesting side part of the whole discussion with this argument as well, because SPAN is an old technology. SPAN ports are around since there are switches. So we're talking about 25, 30 years of technology livability. At that part back then, you were talking about 1G networks, 10G in the backend networks. We're not talking about 40G networks, 100G networks. I mean, it's a simple maths problem, right? If you have a full capacity link with 25 gigs going through that link, and then you have a spam port, what people don't often consider is there is not only information coming from that port, but there is also information going to that span port.
Yep.
So suddenly you're not seeing the whole picture anymore, because 25 gigs going into the network link, but 25 gigs not coming out of that link in that area.
No, I mean, in fact, like you said, we're aggregating that bidirectional traffic. So if I wanted, with a span port, even come close to trying to capture everything, I would always need to make sure that my span port had twice the bandwidth of the port that I was trying to monitor with it, and that the timing was correct. Because now I'm taking packets coming in and going out and trying to weave those together into a single output port going to my analysis equipment. So now we start getting into those timing issues that we run into with span.
Yeah, so we have now identified three things. First of all, we have a hardware issue, a configuration issue with the switch in general, and it's not how switches are intended to be operated by providing a carbon copy of whatever comes in a single port. And the second issue we have faced is that we say, okay, there is an aggregation going on, because whatever comes out, it needs to be aggregated by the switch in order to be presented to the network. Aggregation in general, if it's done with a separate hardware, can lead to issues where, the streams are not synchronized, or there is a delay, or you have two different network engines coming together. You have two different store and forward scenarios, two different interpretation scenarios. I mean, I remember old Windows boxes that used to reorder network packets and present them in the right order to the system. Yeah, good luck finding out a reordering issue with TCP in that regard. And lastly, you have the overall capacity situation where you might have links that's no longer feasible. I mean, we had a discussion with a customer a few days back where he has a monitoring solution in place and he has 425 gig links going into the single monitoring solution, and he does it by using, actually he does it by using 4 different spam ports going into 2 different switches, then going into another 2 different spam ports, going into a packet broker scenario, which then at the other end goes into the monitoring solution. At that point, you're just asking for packet loss. I mean,
yep.
That's no longer a solution to that regard. So what is a solution? What is the? I mean, we all know what the solution is, but it's coming from a different point of view. I mean, the best way would be to just sniff on the cable, right?
Right. Yes.
So this is where the taps come in. Now, what would you say is? I mean, a network tap. What's the best? By the way, taps for people who don't know, called test access points. A little bit of history here. They were never intended for monitoring, which is actually in the original RFC document. Taps were really just written for the network technicians to test if the network is working. And I think for people who don't know taps, you can most easily, say they're kind of oscilloscopes for the network, right? They show you what's going on and nothing else.
Well, it's like a test point. If you look at a printed circuit board, right, you'll see TP1, TP2. So it gives us those test points where we can hook something like the iota up, kind of like the oscilloscope, to go in and start monitoring, seeing what's going across that particular point in the network. Yeah,
and from a technical point of view, I mean, you could now say, well, we're coming back to network hubs, right? A network hub is a tap in general, because everything going in one point comes out in every other point. But by definition, a network hub is half duplex due to that factor. Mm-hmm. Now, a tap is basically what's going on. We have a connection. We're talking about 2 different kind of capture points, like an inline point and an out of band point. Out of band, I think, is the more span-like scenario, right?
Yep.
So you have the situation where you put a tap in. Now, why, or what will I see immediately if I start using taps instead of a span port? What is the big thing what is the first benefit I will reap from that?
Well, I'm going to get everything, right? So I'm getting everything that goes across there, because especially in the case of a fiber tap, I'm splitting the light. So I'm taking a portion of that light and sending it off to my monitoring equipment. So I'm getting the same timing. I'm getting all of the data all the packets that are being passed on to the device that's connected to that tap. I'm getting that information. What I'm also getting with that in some cases that can make taps, we need to architect our network to use the taps, because the taps are splitting my traffic into 2 streams. And so I'm seeing the traffic going in each direction. So if I just want to plug a PC with Wireshark on it in there, it's not quite as easy, right? But now I'm getting accurate timing and I'm getting everything. I think that's probably what you were getting at with that, was it? Or?
Yeah. I think you covered 2 things that I really enjoy with taps. And again, with the industrial Ethernet background, one of the biggest things is you're getting accurate timing. Especially when you have a hardware-based tap like the Profitap devices or the IOTA tap devices, the IOTA Edge devices, where you have actually the possibility in certain scenarios to have nanosecond timestamp resolution on the packets themselves. Now, you might say, I don't need that necessarily, but what you also get is you get an exact copy picture of what's going on the packet. With Wireshark, we often have the saying, packets never lie. But also every network specialist knows the network is always the faulty point, right? If something goes wrong in the company, it's the network's fault.
Yes.
Cannot be
it's always the network.
Right. It makes your life easier to prove either it is the network's fault or it isn't, if you can guarantee that everything the tap sees is actually what's going on. And this is, I think, also one of the biggest differentiation between taps out there. There are actually taps you can buy for a few $100. There are taps that are quite a little bit more expensive than that. And I think the difference between those two is one doing the hardware-based timestamping, one going back to the software. There is a variation in how you can implement a network tap. But one thing taps aren't. Taps usually don't need to be configured, right?
Right.
That's the big picture. You don't need to configure it. You don't need to learn it. You set up your monitoring hardware and you get what you need to do. Now you mentioned fiber taps, which is actually kind of neat. Being able to going into the fiber and being able to directly cope with the light. One thing I think with fiber taps, especially in modern scenarios, is also network security point of view, right? So you have this capability of guaranteeing on a physical layer that whatever you do monitor in the network cannot influence the network itself.
Including the tap, right? I mean, we need to make sure that if I put a device, especially when it comes to copper, if I put a device in line, that device isn't going to cause a network failure. And so, I mean, that's something that we need to take into consideration when we're looking at a tap, is that fail-safe capability so that we can ensure that we're not putting a failure point into the network.
So from a technical point of view, one of the things that is a big issue with monitoring hardware. When you put a span port in the network and the switch goes offline goes your monitoring solution, right?
Yep.
Offline goes your whole network. When the taps go offline, well, your network keeps on running. That's the main consideration here.
Well, and I was going to say another one is that we don't ever want our monitoring equipment to adversely impact the traffic that's going through, right? So Profitap has some solutions for being able to take that into consideration too. And that would be the data diode, right?
Yeah. So where you have a physical guarantee and a technical guarantee that you get the information only in one direction, whatever you send through the tap doesn't affect the network or cannot affect the network. In a certain sense, with the fiber optic taps, you have a pure physical interface. You don't have any kind of software interference with that. So that actually makes it very safe to deploy in sensitive areas, in security-prone areas, or in areas where you have a timing sensitivity, right?
Yes. Well, and then access to that data. And so that's another one we've seen with SPAN is having that SPAN port sitting out there, especially if we forget that we've set up a SPAN port, we're now giving somebody a view into that traffic going across the network. So in a lot of situations, we want to be able to ensure that only the people that should be seeing the data are seeing that data. And by having that tapping infrastructure in place, and especially where we can secure those taps, that becomes critical in maintaining that network integrity and security.
One more thing when we go into the direction about saying, okay, I have the span situation, but I want to go towards taps. One thing that taps can additionally do is filter and aggregate, right? So when you have a monitoring solution on the other hand, and it only has a limited capability of input streams, but you have a huge vast network and you want to monitor certain areas, I think one of the beneficial factors here is that you don't need to pre-select what information goes into the monitoring solution and what isn't. You can, on a scenario-based situation, decide, okay, I want to see those streams, I want to see this information, or I don't want to see that kind of traffic in the monitoring solution itself, right?
Yep.
It's kind of, having the how would you say, having the Band-Aid in place, just not applying it yet, and applying it when you need it, and removing it without affecting the wound in itself.
I guess I've always, whenever I've talked to people about, setting up a new network, Oftentimes we see that they put the UPS down at the bottom of the rack, right? So we wouldn't set up a rack of equipment without having some power protection. So I've always been a big fan up at the top of the rack between our network equipment and our patch panels to have our taps in place and really look at that tap as an important component, as important as our backup power, to being able to go in and monitor that. Because at some point, just like you mentioned, there's going to be an application problem, there's going to be a security breach, something's going to happen. They're going to want to be able to see that network traffic. And I may be in a situation where I can't take down the network to put a tap in place temporarily. Nobody wants me to change any of the configuration because we're trying to resolve the problem. We know if we change the configuration on a switch, that could change what's going on. So having that in there, as you mentioned, in a preventative manner. So now, even if I'm just doing a temporary capture and I plug into that tap, it gives me that test point in my network. In an ideal situation, I'm taking the fiber copper out of that tap, I'm putting it into that patch panel, and I'm feeding it back to my data center, and I'm aggregating that together, and I'm automating that process. But just kind of keeping in mind, when I build a rack and I start putting equipment in there, tapping those uplinks becomes a very cost-effective thing to do at the beginning. Because those taps at the beginning are just a fraction of the overall cost. But going back in and putting them in later and having to take downtime and so on can be not only another cost, but also affect system availability.
So if you would say somebody has currently applied a span scenario, is planning a new data center, a new network center, and wants to start off with tapping, not necessarily go full-blown installation, but say, okay, what are the key points? How would you start identifying what kind of key points he can apply the taps initially to ensure that he gets the best out of the buck he invests?
Well, I mean, I would say that, if as far as putting taps in my MDF, right? So putting my taps in place where I'm distributing my traffic out to my wiring closets throughout my environment. So anywhere where I can tap into that flow of data going out to the switch becomes critical, because I want to see, is the packet getting there? And that's, anytime we're troubleshooting, is it getting to the end destination? And if it is, why isn't it working properly? And then once we can see that, then we can start digging in deeper. But certainly laying that foundation, making sure that we're putting those fiber taps in our links, even if we don't have an overall monitoring solution yet. Because we can always add on. We can connect our packet brokers up to those taps and start pulling that data together, or we can temporarily connect to them. But I think one of the first steps is making that decision that as part of your network deployment, you are also going to begin the process of building a monitoring infrastructure. And that begins with the taps.
Well, I would say this actually puts a nice bracket around our topic today. And I would say this was a really nice conversation for our first installment of the Profitap talks, Profitap talks. And yeah, thank you, Mike, for joining.
My pleasure.
Thank you, viewers, for listening and watching. And look out for the next installation of this series. Thank you very much.